Welcome to today's tutorial. So in this tutorial we're going to be finding limits when x is approaching either positive or negative infinity. So if you have not yet subscribed to the channel, make sure that you do so, and also don't forget to click the notification button so that you don't miss out the videos that I'm going to be posting. And seeing that you have a lot of tutorial sheets released at once, I'm going to be solving random questions from different tutorial sheets at once, so that you can be up to date with everything. At least when you are going to write your tests, or your at least at the time you'll be writing your test 2. I don't know if it's your test 1. At least you should have ideas on every question they are going to bring. So I'm going to be mixing up the questions. Today I may solve maybe questions from tutorial sheet 1, 2 and 3, and then maybe the other day I just solve from tutorial sheet 4. Then so I'm going to be doing that, and then if you have a specific question you want me to solve, you can send it over on WhatsApp, and then I'll be using the textbook Thomas Calculus so to assist to solve the questions. Alright, so let's quickly solve these questions. Okay, so the first question says we find the limit, if it exists, of x over 2x minus 3 as x approaches positive infinity. So this this question is only based on one concept. That's what I can just say. So the only thing you need to know about such a question is that the limit as x approaches the positive or negative infinity of 1 over x to the power n is always equal to 0. So this is the concept that you need to know for you to solve all these questions here. Okay, so for example, if you have maybe the limit of 1 over x squared as x approaches positive infinity, the answer here is simply just going to be equal to 0. So this n can be any integer. This n can be any number in short. Alright, so let's quickly move on to solving the question. So I'm just going to solve a few questions from here, of course random questions. Then after doing that, I'll leave certain questions for you to also solve, so that you can submit as a practice exercise. So I'm not going to be solving everything. I'm going to be solving a few questions and leave some for you to solve. Then you submit through my WhatsApp line, which I showed you on the screen. Okay, so we start with the first one there. So we say that we have the limit as x is approaching positive infinity of x over 2x minus 3. So what we do for us to solve this question is we're going to check the function to see which function has the highest power in this expression. Which term has the highest power in this expression. So if you check the numerator, the highest degree there is 1. So you can either call it a degree or a power. So the highest degree there is 1. The denominator there, the highest degree is also 1. So you can just divide the whole function by x. So on top there, I'm going to divide x by x, and then also the denominator I'll divide it by x. So I'm going to say the limit as x approaches infinity of x over x, then everything divided by, we have 2x over x, and then we also have minus 3 over x. It's just a matter of dividing everything in the function by x. So when we divide everything by x, the numerator there, x over x, will give me 1. Then on the denominator, 2x over x will give me 2, and then 3 over x will give me 3 over x. Okay, so now we find the limit of this expression when x is approaching infinity. So the first part here will give us what? Okay, so the first part the limit of 1 when x is approaching infinity, the limit of any constant when x is approaching any value is simply just that same constant. So on top we will remain with 1. Then the denominator there will give us the limit of 2 when x is approaching infinity is simply just 2. But the limit of this, so we say minus, so the limit of this expression here is just it's in this form in short. The limit of that expression here, this is we can say 3. Okay, let me write it so that you see what I'm talking about. So we factorize 3 there, will remain with the limit of 1 over x as x approaches infinity. So the limit of this part, the answer will just be a 0. So 0 times 3, the answer will give us 0. So what we just remain with is 1 over, here we have a 2, which is there. Then we have minus, this expression here gives us a 0. So we say 3 times 0, the answer will be 0. So the final answer gives us 1 over 2. So I had to show all these parts so that you know what is happening. Let us quickly move on to the to this one here. So even this one, we check the expression which has the highest degree. So the highest degree is, the one which has the highest degree is simply just x squared here. So we have squared there. So we're going to divide the whole function by x squared. So we're going to have, so we have the limit of x over, we divide it by x squared, and then everything, even this one, x squared, we divide it by x squared, and we say minus 4 over x squared as x approaches infinity. So when we do this, so on top there we're going to remain with 1 over x, and then the denominator there we're just going to have 1, x squared over x squared will give us 1, then minus 4 over x squared. So we still have the limit as x approaches infinity of this expression. So when you find the limit of the numerator there as x approaches infinity, remember what we said according to this expression here, it's just equal to 0. Then everything down here, we have the limit of 1 when x is approaching infinity is simply just 1 since it's a constant. Then this part here will give us a 0 as well. So we have minus 0. So the solution will just be 0 over 1, which is just going to give us a 0. So this is the solution for the second part. So we can also do the third part. We do the same thing. Nothing is different. So we'll do everything here. So from there I'm going to also choose, maybe I'm also going to solve this one. So I'll also solve this one. Yeah, and then we'll see if we can also solve other questions. Okay. So let me solve this one. I'll also solve this one. Okay, we'll see. I'll just be solving random questions. Okay, let's solve this one. So this one we're going to divide everything by x to the power 3, since it's the highest. It's the highest power there. So we're going to have the limit of 3x to the power 3 minus 5x to the power 2 plus 7, everything over x to the power 3, everything over x to the power 3, everything over x to the power 3, then everything divided by, we have 8 over x to the power 3 plus 2x over x to the power 3, then minus 5 x to the power 3 over x to the power 3. Then as x approaches infinity. Okay, so when you do the division there, you are going to have the limit. So this one and that one will cancel, just remain with 3, minus there you remain with 5 over x, then you have plus 7 over x to the power 3, then everything divided by 8 over x to the power 3, and then plus 2 over x squared minus 5 when x is approaching positive infinity. So this one will give us a 0, this one will give us a 0, this one will also give us a 0, this one will also give us a 0. So we just remain with 3 and -5. So the limit of 3 and -5 there, when you find the limit of independent terms, this, and that will give us a 0. So just remain with 3 over -5, which will just give us -3 over 5. So this is a solution to this. So I've done a shortcut here because I believe you know what is happening. Okay, so even this one, whether it's negative infinity or positive infinity, just have to divide everything by the highest power. So in this case, we're going to divide by x to the power 2. Yes, and then when you divide everything by x to the power 2, you get your solution. Yeah, so the solution here will simply just be, so on top there we have a 1, even down here you can see a -1. So the solution, I'm sure it can be -1. Okay, let's move on to, let me solve this one maybe. Which one can, okay, I'll solve this one and then I'll also solve this one. So once I solve these two, I'm sure you can solve the remaining ones based on the explanations I'm going to give on the ones that I've solved and on the ones that I'm going to solve. Okay. Okay, so let's take a look at this one. Okay, or let me start with this one first and then we go to that one. So I'll do this one. So we have so on this one we have the limit of 2x minus 1 everything divided by the square root of 3x squared plus x plus 1 as x is approaching positive infinity. So if you have this, then you are going to divide everything by x, because x is the highest power in this case. If you want, you can say the square root of x squared, which is just the same as x. So when you do that division, we'll have something like this. The limit as x approaches positive infinity, so we divide everything by the square root of x squared, which is just the same as x. So when you say 2x divided by the square root, I'm saying the square root of x squared because we're trying to remove x squared from this square root. So this is just the same as x. So it's just the same as dividing everything by x, and you say minus 1 over x, and then everything divided by this part is also the same as the square root of 3x squared over x squared, then plus x over x squared, and then plus 1 over x squared. So when you have such an expression, this part here will give us a 2. So we're going to have the limit of 2 minus 1 over x, then everything divided by, so this part and that part will go. Here we'll have 1 over x, and then there we'll have 1 over x squared. So we're going to remain with the square root of 3 plus 1 over x plus 1 over x squared. Then as x is approaching positive infinity, so from there we can do as this, we can distribute the limit to all the terms there. So what we're going to remain with is, so the limit of 2 when x is approaching infinity will give us 2. The limit of this part when x is approaching infinity will give us a 0. Then down here the limit of this part will just give us the root of 3, and then there you get a 0, then you also get a 0 on that other part. So meaning the final solution you're going to have is just going to be 2 over the root of 3. So this is the expression, rather this is the answer to this expression. Alright, so for this one, when you're finding the limit of this expression when x is approaching negative infinity, we're going to take the negative side or the left side of this mean the negative side of this absolute value. So how do you do that? So you're going to have the limit of 2x minus 5, then as x is approaching negative infinity of, so this part we get